Hi everyone. Today I'm here to say something about software quality assurance. Firstly, what is software quality assurance? Uh, Software quality assurance ensuring the consistency delivery of high quality software product is the core function of software quality assurance. Uh, this encompasses a range of methodologies and standards, including the renowned ISO 9000 and SEI CMMM framework, which provides comprehensive guidelines for achieving excellence in software development. Move ahead and see some more points. Uh, Now, ISO 9000s, that's overview and key principle. There are three key points. The first one is quality management system. The second one is process oriented approach. The third one is a continuous improvement. The first one, quality management system. ISO 9000 is a set of international standard that defines the requirement for a quality management system QMS, and it provides a framework for organization to consistently deliver products and services that meet customers and regulatory requirements. The second point, process oriented approach. The ISO 9000 standards focus on the process oriented approach, emphasizes the importance of identifying and managing interrelated process to achieve desired output. The third one is a continuous improvement. A key principle of ISO 9000 is the commitment to the continually improving the effectiveness and efficiency of the QMS. This drives the organizations to identifying and address areas for improvements. Move ahead and see the SEI CMM SEI capacity maturity models, its levels and characteristics. The first level, initial. The second one is repeatable. The third one, define. The next, manage and optimizing. The initial level, processes are ad hoc and chaotic, with little predictability or control. Software development is often reactive rather than proactive. The second one is repeatable. Basic project management processes are established, allowing for more consistent software development. Processes are documented and followed. The third one is defined. Processes are well defined, standardized, and integrated across organization. There is a strong focus on process improvement and knowledge sharing. The fourth one is managed. Detailed metrics uh, are used to manage and control the software development process. Quantitative performance goals are established and meet. The fifth one, optimizing. Continuous process improvement is embedded in the organization. Innovative approaches are used to optimize the software development process and achieve measurable improvements. Move ahead and see some more points. That is a comparison of ISO 9000 and SEI CMM. In the four bases, the first one is a scope, second approaches, third one is deployment, and the fourth one is a certification. The first one, scope. The ISO 9000 is a broad quality management system, while SEI ICM is a focused specifically on software development process. On the basis of approach, ISO 9000 emphasizes documentation and standardization, whereas SEI CMM emphasizes continuous process and process improvements and maturity levels. On the basis of deployment, ISO 9000 is widely adopted globally across industries, whereas SEI CMM is primarily used in the software industry. Now, on the basis of certification, ISO 9000 certification is awarded by the uh, aggregated external bodies, whereas SEI CMM assessment is performed internally. Move ahead and see software maintenance importance and its challenges. Software maintenance is a critical phase in the software lifecycle, ensuring software remains functional and up to date. The this phase addressing bug fixes, performance improvements, and adaptation to changing requirements. However, software maintenance can be complex, with the changes such as legacy system, insufficient documents, and resource constraints. Further, move ahead and see maintenance process model. There is three types of maintenance model: corrective maintenance, adaptive maintenance, and perfective maintenance. The first one is a corrective maintenance, addressing issues and defects that arises during software operation to restore proper functionalities. The second one is adaptive maintenance, modifies the software to accommodate changes in the environment, requirements, or user needs. The third one is a perfective maintenance, enhances the software performance, efficiency, or user experience based on evolving demands. Move ahead and see some more points. That is the maintenance. Corrective maintenance involves fixing bugs, errors, or issues that arises in the software system. It is a reactive process that addresses problem as they are reported by the users or discovered by the development teams. This type of maintenance is crucial for ensuring a software product continues to focus as a intended or meet user requirement. It helps maintain the software reliability, stability, and overall quality. Move ahead and see adaptive maintenance. Adaptive maintenance focus on modifying software to ensure it remains functional and effective as the operating environment changes, such as a new hardware, software, or regulation. This involves proactively updating the code base to address involving user needs and technical advancement. By anticipating and addressing future requirements, adaptive maintenance helps maintains the long-term viabilities and competitiveness of the software system, ensuring to continues to meet the business objectives. Move ahead and see perfective maintenance. Perfective maintenance is basically perfective maintenance is basically maintenance focus on enhancing the software functionalities, performance, and user experience. This involves adding new features, improving existing one, and or optimizing the code base to meet evolving business requirement and user needs. Perfective maintenance is a proactive, driven by the desire to stay ahead of the curve and ensure the software remains competitive and relevant in the market. The now in the last slide, or that is the last point, but very important in software engineering, that is the reverse engineering. Reverse engineering concept and application. Reverse engineering is the process of reconstructing and analyzing a product or software or system or to understand its inner working, design, and functionality. This powerful technique allows engineers to recreate or modify existing technology, improve upon the improve upon them, and develop innovative solution that builds upon the foundation of the previous work. Key application of reverse engineering includes software development, mechanical engineering, and electronics. By carefully deassembling and analyzing existing system, engineers can uncover hidden insights and create more efficient, reliable, and innovative solution to the complex problem. That's all from for this video. Thanks a lot for watching these videos.